We want to determine if these lines are parallel, intersecting, or neither, which we call skew. So looking at these two lines, we can start by looking at the direction vectors. The first line has a direction vector of 2, 3, 4, whereas the second line has a direction vector of -4, -6, -8. Now you might notice that this vector is exactly -2 times the first one. So -2 times the vector 2, 3, 4 is -4, -6, -8, which tells us that these two direction vectors are parallel. And if the direction vectors are parallel, then so are the lines. So these two lines are parallel. Now let's look at some other ones. So now we have two new lines. Looking at these, it's pretty clear that they're not scalar multiples of each other. And so now we have to consider, could they be intersecting? To determine that, we have to ask the question, is there a pair of values, is there a pair of values, t, and we'll pick another variable, s, so that r1 at t is equal to r2 at s. Now, so we don't care if the lines are at the same point at the same input. We wonder if there is some input for the first function and some input for the second functions where they'll be equal. So what we're going to do is we're going to set the components equal. So looking at the x components in the first equation, we'd have 1 plus 3t. In the second line, again, we're using s as the input now, 2 minus 1s as the x component. So we're wondering, is there a pair t and s that'll make this true, as well as the similar equations for y and z? So 3 plus 4t and 11 plus 2s. Now, to solve this, we're going to have to pick a pair of these and solve them as a system of equations. So perhaps I will pick these two here, and I could take the first equation and solve it for t. So t equals, subtracting 2 from both sides, 7 plus 3s. And then substituting that into the second equation, 3 plus 4, now we're going to replace t with 7 plus 3s, equals 11 plus 2s. And we got 3 plus 28 plus 12s equals 11 plus 2s. So 31 equals 11. Now we're going to subtract 12s from both sides, so minus 10s. Negative 10s equals, now subtracting 11 from both sides, 20. So s will be -2. And when s is -2, going back to our substitution here, t will be 7 plus 3 times -2. So 7 minus 6 is 1. So this is telling us that when t is 1 and s is -2, that the y components are equal and the z components are equal. But that doesn't necessarily mean that the x components are going to be equal. So now we need to check the x. So we need to say, is 1 plus 3 times the t value we came up with equal to 2 minus 1s, where -2 is the s value that we came up with? Well, let's see. 1 plus 3 is 4. Is that equal to 2 minus a -2 is 4? Yes. And so that tells us that not only are the y and the z components equal, but the x components are equal as well. And knowing that, that tells us these lines intersect.